All right. Greetings, wonderful people. So we're going to go ahead and continue with what we were working on yesterday. So yesterday we were working on some of these things like see if a given relation is a function or not, finding the domain and range of a function or relation, rewriting in function notation, and evaluate functions with given input. So it's that last point that we kind of didn't really get all the way through on, and pretty much I think every class got to a different point, so I'm going to go ahead and just start from the beginning. So this is actually the second page of that packet, and I'm going to do a quick rundown, or if we didn't get to this point, then it's going to be the information that you'll need. So equations that represent functions are often written in function notation. So you are familiar with something that looks like this. So this would be a linear function. So this is algebra 2. So you're probably very used to working with linear functions. Those are the y equals mx plus b, straight lines with slopes and intercepts. And over here I have the same thing. Actually, it's not exactly the same thing. It looks like there's a typo here, because there's not supposed to be a negative there. But it is the same thing, 2x plus 7, 2x plus 7. The only difference is that we replaced y with f of x. So we write it this way, so it's a little bit easier to read. So you can easily spot your inputs and outputs. So x is the input and y is the output. So function notation is useful for finding a value in a range that corresponds to a certain domain. So for example, if they have something like f of x equals 2x plus 7, find f of 3. So one thing they could do is look at the f of x, and this part here is your base function. And it's kind of like the starting point. So what we're going to do is we're going to just drop in f of negative 3. And I'm going to put the whole thing in there too. So wherever I see x, I'm going to place negative 3 there. So this is going to be 2x. But instead of x again, we're going to replace it with negative 3. So that should be the same thing here. And now we can evaluate it. So go ahead and put this here. So I have equals negative 6 plus 7, because that's going to be 2 times negative 3. And that's going to be negative 6. And the plus 7 just sort of stays where it is. And now I'm pretty much done with this one. I just need to write the last step, and that would be to put it in function notation. So f of negative 1, or actually in this case, negative 3, equals 1. Because 7 minus 6 would be 1. And this is actually the answer that we need right here. Because this is telling us right here that this is the input. The input is negative 3. All right, so if the input is negative 3, this means that our output is 1. So whenever you have something like this, well, here's an easy way to think about it. So function, everything has a function like around us, right? Humans, we put things together, we build things that usually have a function. And I'm going to start off with something that's kind of easy that we should all be familiar with, and that is a toaster. So a toaster is a simple mechanism. It's just a heating element with a spring-loaded platform that you put toast in, and then you push the button down for about a minute. Well, you don't hold it down for a minute, but you push it, and then about a minute later you get toast. So you have an input, which is bread, and you have an output, which is toast. And that's the function of the toaster. The function is that it turns bread into crispy, warm toast. And there's always going to be inputs and outputs. Like for instance, one of the other examples I usually give is Pringles, just because I have it with me here today. So I have another can right here. And it's about $1.69 for one can. And in this case, like let's say I brought the cashier, 3 boxes of Pringles or 3 cans of Pringles, and that would be my input. My input is asking the cashier that I want 3 boxes of Pringles, 3 cans of Pringles, and I would get something like $5.07 or something like that. So that's the output. The output in that case is the price because I'm the one who dictates how many I want. So it's not the other way around. I can't go in and, well, I guess I could, but I'd have to do, it would be a little bit weird and out of the ordinary for someone to say, I want, $20 and I want as many Pringles as I can. Usually they're gonna have to keep adding or subtracting them until they get to the number that they want. So yeah, functions are kind of everywhere. They're always gonna kind of be there. And here I have some more of them. So with this one here, I'm going to be using this here, f of x equals negative 5x minus 14. And for g of x, so if I see a g, I'm going to have to use this equation, which is negative x squared plus 9x minus 1. And I'm going to go ahead and start evaluating it. So I already have f of 9 here. So I'm going to go ahead and take my f of x. So that's going to be negative 5x minus 14. But I'm going to take out the x and I'm going to replace it with the parentheses because now I need to put in negative 9. And that's pretty much it. From here, we just evaluate it like we would with any normal expression. So 5 times 9 is 45, which would be 45 minus 14, which in this case is 31. And for now, I just need to rewrite it in function notation because that was one of our objectives. One of the things that we have to do is write it in function notation. So in this case, we would have f of negative 9. So if my input is negative 9, my output will be 31. So again, this machine, if I put in a negative 9, I get 31 back out. All right, so here we have a fraction. So it says here f should be 3/10. So I'm gonna go ahead and take my f function. And let's go ahead and plug this in. So negative 5x, but in this case here, I'm gonna have to use an x of 3/10 minus 14. Now, let's see, I'm gonna have to use my rule of fractions. So I'm gonna multiply this. So negative 5 times 3 would be negative 15 over 10, and that would be minus 14. And remember, the bottom number stays the same, or you can put a 1 below the 5, and that will make it so that there's a 1 on the bottom. So I have negative 15 over 10. And in this case here, I can also use long division in this case here. So 15 divided by 10 goes in there once, and I have 5 left over, top number. So in this case, it'd be 1.5. So negative 1.5 minus 14. And since they're both negative, I'm gonna have to combine them. So in this case here, I would get f of 3/10. So if my input is 3/10, my output will be 15.5. And that should be the answer I'm looking for in this case. Okay, so I'm gonna go ahead and move on to the next one. So these aren't really that tough. I don't think this would be very tough for most of you guys. I think you guys are would be pretty okay at this. It's just evaluation, and I think you've even done some stuff like this. So anyway, back to number 3. We got negative 5x minus 14, but in this case here, instead of x, I'm gonna replace it with 0.4. So I'm going to multiply 0.4 times 5. And that should be 0.4 times 5. 0.4 times 5. And that looks like it would be 2. actually, hold on, would that be negative 2? Negative 5 times x. Oh, hold on a minute. I was thinking this doesn't look right. That's because we're supposed to be using the g function. Make sure you're using the right function on these. So actually, in this case here, I would need to use this one here. So negative x squared plus 9x. And again, I'm going to replace it with parentheses. Now, with some of these, you've got to really pay attention to where you put the parentheses because it will make a difference. Like in this case, see how I wrote it with just the negative there? Because there's supposed to be an x here, but when I take out the x and replace it with 0.4, the negative is on the outside. And that does sometimes, well, actually most of the time, it will make a difference on exactly how this goes together. So in this case here, I have 0.4 squared, which if I have my cheat calculator, which just about everybody should have one of these. Okay, they have them at the dollar store for like $1 or so. And that negative is still going to be there because even though normally a negative times a negative would be positive, in this case here, that's not the case because the negative is on the outside. So it's not affected by the square. And then 9 times 4, there's already 0.4. That would be 3.6 and then minus 1. So in this case here, let's see, we got 3.6 and it looks like I'm gonna have to minus 1 and then minus this 0.16. And that gives me 2.44 for this one here. And now we have our final answer, 0.4 equals, so if my input is 0.4, I get 2.44. Okay, and there you go. So again, it's just a matter of evaluating. All right, now this one is -7, so that's the one I'm gonna have to put in there. So the thing I'm gonna have to write is -7, and we have to use g, so let's make sure we're using the right function this time to start with. Plus 9x minus 1. And instead of this thing here, I'm gonna have to replace it with -7. Oh, and same thing for this one here. I'll almost put that there. So now we have -7 in here. Now, even though this one does have a negative, remember a negative times a negative is positive, but there's still a negative on the outside of this right here. So there's the negative on the outside. So the negative is not changed, but there I have -7 times -7, and that would be 49. So it's still going to be negative, even though we had a square, still going to be negative. And then from here, I'm going to go ahead and put these two together. So I get -112 minus 1. And, well, it's all kind of negative. So from here, actually, I think I have enough information to go ahead and just write in my function notation. So again, that's part of the objectives that we had. So make sure that you would write these in function notation. Okay, you got to write it in function notation because that's, again, the objective is to write it in function notation. So this again means that if I place in -7, I will get out -113. All right, so here I have two of them, right? I have an f of 1 minus f of 4. So there's actually going to be two functions that I have here. So for the first one, I'm going to have to use, well, actually for both of them, I'm going to have to use x, so -5 x minus 14. And then, well, actually, I'm going to do one at a time. Just do one at a time. So there's the first one here. And you can, in a way, write these all at once. Oops. You can write these all at once, but I'm gonna do it one at a time just so you're not confused. So I did the same thing. Just take this, plug in 1. And that would be -5 minus 14. And then combine these two together, you get -19. So that's the first part. That's this part right here. For this second part, I'm going to go ahead and do this one. And we have f of -4. So I'm going to ignore this negative. We'll come back to this later because this one here we're not working with just yet. So we're going to come back to that. So -4, or actually hold on, -5x, and this would be -4 minus 14. And in this case, 5 times -4 would be 20, positive 20, minus 14. And 20 minus 14 would be 6. So actually, in this case here, we would have, well, if I rewrite it, right, because there's going to be a negative here. So I have -19, which is the first one. And then I have a minus. This one is the one in the, right here. It's this one right here. Minus the one we got from the second part, and that would be 6. So in this case, I have finally put these two together. So grab this one and subtract that one. From here, we should have enough information because it's just -19 minus 6, and then we'll be able to put them together. So in this case here, well, I'm just going to put -25. Because in this case here, we have, you know, I'd have to write this whole thing out. I'd have to write, that's weird. Where did it go? Okay, but yeah, otherwise I'd have to write this whole thing out, but don't be afraid. You know, this is good enough. All right, now on to this one here, g of 12. And I'm going to do the same thing. I'm just going to work on one thing for now, and that's just the g of 12. So -x plus 9x minus 1, and it looks like I'm going to have to put in the square. Just double check it, make sure we're not missing anything, because now I'm going to have to drop in a 12 here and here. And again, that's this 2 right here. We haven't done anything with it. We haven't gotten to it yet. We'll get to it in just in a bit. So now we have 144, because that's 12 times 12. But the negative, again, is on the outside, so it's going to stay negative. So make sure you're doing what I'm doing, if you're not sure, and that is to replace the x with a parenthesis and then drop in a negative as soon as you can. And in this case, 9 times 12 is 108 minus 1. All right, and then 144 minus 108. Looks like we're gonna get -36 minus 1. And okay, we need to go a little bit further. In this case, it would be -37, but we're not done yet, because remember I said that we gotta work with this 2. So this is 2, and I'm gonna change the color to purple to show that that's the original. And now we have to plug in right here, we have to plug in g of -37, or sorry, g of 12, which we know is 37. So remember, g of 12 equals -37, so I'm going to put in -37. And that should be enough for me to get the answer we're looking for. So all this will just boil down to -74. And I probably should box all of these, just to go around, box all of them, because this is the answer we're looking for. These are all what we should write our answer in, because again, that was one of the objectives, is to write it in function form, function notation. Okay, let's go ahead and move on to the next thing. And it looks like here we got some stuff with fractions and absolute values. So we have P and Q functions. So again, anywhere we see a P, we're going to use this function. And anywhere we see a Q, like right here, we're going to use this function. Now there's a lot of fractions in this one here. So I'm going to go ahead and just do I'm going to just kind of write all this out. All right, so it looks like we got our first one where it's P of -9/16. So let's go ahead and take our function and I'm going to plug in. Okay, not yet. We don't need that yet. Now we need it. So negative 9/16. And that's pretty much it for this one here. So let's go ahead and multiply these two together. And we could cross cancel, which let me think. You could multiply this out. So like 9 times 4 would be 36. And 3 times 16 would be 48. And then, you know, divide by the largest number you can think of, which in this case I think would be 12. But in this case here, I'm also going to use cross cancel. So 4 and 16. Now this works just like simplifying. Just like simplifying. If you can imagine a fraction like 4/16. All right, divide both of them by the biggest number you can. So in this case, divide this by 4 and take my bottom number and divide that by 4. So we get 1/4. So that's cross canceling. And I can do the same thing with 1 and 3 because divide this by 3 and divide this by 3. Now I have much smaller numbers to work with. 3/4. Because that's all that's left. 3 times 1 is 3 and 1 times 4 is 4. So 3/4. Now here's where it gets a little tricky because this is, again, one of those things that we have to learn how to do with fractions, and that is if I'm going to subtract fractions, and in this case, I think you might be able to get away with converting to decimal. So, but that if you know me, again, I like to do fractions because I think it's better. So what I'm going to do is I need a bottom number that matches. So when it comes to fractions, it's always about the bottom number. That bottom number really will set the stage for anything that's going to happen with these numbers. So in this case here, I'm going to take 1/2 and I'm going to change it to 2/4. So I'm going to double it. So we know how to simplify or reduce a fraction. But in this case, we're doing the opposite of, we're really doing the opposite, and we're making it bigger. We're making the terms larger. So I basically doubled my top number and doubled my bottom number. Now, one thing that kind of, I think, something that kind of, I wouldn't say bugs people, but I guess it would confuse people is oftentimes they look at two fractions like 1/2 and 2/4, and they think, oh man, those are different numbers. Well, yeah, okay, yeah, they are different numbers. But if I take 1 divided by 2, so 1 divided by 2, or 1 with a 2 on bottom, that'd be 0.5. 2 divided by 4 is also 0.5, so it doesn't actually change. They're not different numbers, they are the same number. Which is one thing that's kind of confusing about fractions. You can have two things that look very different, but they actually mean the exact same thing. And that's how you would, again, change this. But the second one, I don't need to change it because it's already got a bottom number of 4. So now I do the same thing and leave the bottom number the same, so that they're both 4. 2 minus 3 is -1. So in this case, answer is going to be, oh, wait a minute, hold on. You know what, I think I just forgot something here, and that was I forgot to put a negative here, which is actually going to mean that this is a negative times a negative, which would actually change this to a plus. And that actually makes things a lot easier, actually, because now I have 5/4, which in this case, this is what I'm looking for right here. So if I can get this whole thing down to one number, that's going to work out a lot better. Okay, now let's go ahead and move on to the next one. So I have Q of 5. So with Q of 5, let's go ahead and take 5 and plug it into this thing right here. So this one's a lot different, and some of these look really confusing, but honestly, they're not so bad. So just start plugging things in and see where it takes you. That's usually the hardest step with math, is to get started, because I know sometimes it looks like you look at these problems and you're thinking to yourself, oh no, I have a lot of work to do. All right, so 3 times 5 would be 15 minus, and then I have This negative is not included here. So this is only 5 to the 3 power. So in this case, it would be 125. So this negative again is not affected. So it's gonna come down to the next step. And now I have 15 minus 125, which is going to be a negative number. It's going to be a negative 110. So here I have the absolute value of negative 110. So Q of 5. So if my input of 5, I will get, and again, remember, absolute value is going to turn that into a positive. So I get positive 110. And actually, in this case, I did not write the P of negative 9/16 because I kind of ran out of space, although actually I really should do that. I really should put the fraction notation in there. So P of negative 9/16 equals 5/4, or about 1.25. All right, now we got the same thing, but we got -2 for Q. So let's go ahead and take this and plug in -2. So 3 times -2 minus x to the third, but again, x is going to need to be replaced with a -2 to the third power. And let's see, 3 times -2 would be -6 minus, oh, and this minus is not going to be affected, but this one will be. Actually, in this case, we might actually get something a little bit different because it would be -2 times -2 times -2. So I'm going to have to start with one side. So this would be 4 times -2, which would actually give us -8. So in this case, we would end up with -8. Now, cube functions are a little bit weird because they don't always mean whatever you put in there is going to be positive. Not like a square number or a 2 power. Those will almost always become positive. Well, I can't think of any cases they wouldn't be positive, so they're pretty much always going to be positive. So let's see, -6, and I'm going to change this to a plus. And I get 8 minus 6, which is going to be the absolute value of 2. And now again, let's go ahead and put this into our function notation. So now that one's done. Okay, now let's go ahead and do this next one here. P of 18, so we got to use this function here. So this is equal to 1/2 minus 4/3 x, which in this case x is 18. And I'm going to do something a little bit different. I'm going to plug in 18/1, just so that way it might be a little bit easier to work with, because doing 18/1 makes your fractions line up a little bit easier. And you don't have to do this again, but look at the top and bottom numbers. Now this is again cross canceling. Don't confuse this with cross multiplying because it sounds the same. But again, it's just like if you were to take 18/3 and reduce it, right? So in this case, they can both be divided by 3. So 3 divided by 18 is 6, and 3 divided by, well, 3 is 1. So this is basically the same as changing it to 6/1. And now I have 4 times 6 as my top number. 4 times 6 is going to be, 4 times 6 is 24. I'm pretty sure it's 24. Now my bottom number, 1 times 1, is going to be 1. And I would need matching numbers but on the bottom number, but actually in this case here, well, it would be 1/2 minus 24. And if you ask me that question, I'd say I would say that it's -23.5. But then that's just something I know. I mean, I work with fractions a lot, so I'm going to go ahead and change this so that way we have a 2 as the bottom number. So I need these two bottom numbers to match. And that means I'm going to have to double one of my numbers. So in this case, it's going to be this side. So double 24, you get 48. Double the bottom number, 1 times 2 is 2. Now I can go ahead and subtract it. So this would be negative 47 over 2. And I can do my long division if I want a mixed number. So 47 divided by 2. Now I'm also going to have to remember that this is going to be a negative. Oops, I don't know what number it's going to be, but I know it's going to be a negative. So I'm going to put a negative right here so that way I don't forget it. 2 goes into 4 2 times, and that's going to cancel out completely. 2 goes into 7 3 times, and I would get 6, and I get 1 left over. So that would be minus 23.5, and P of 18. So P of 18 equals negative 23.5. So if I plug in, if I have an input of 18, I would get negative 23.5. Now I'm also going to show you something a little bit different. So yesterday we worked with Desmos, and I also told you guys too that the sooner you can kind of realize that all of this is really just kind of the same thing. So remember, you can have an equation, a mapping diagram, a table, or in this case, a graph, and they all mean the same thing. They're all different ways of describing the exact same thing. So the one we just worked on, let's go ahead and plug that in. So that was the Q function, or was it P? No, we worked on P. So for this one here, P of X, but I'm going to replace it with Y because in fact, I don't really even need it. So I'm going to go with 1/2 minus 4 over 3 times X. So this was the function that we just got done looking at, okay? Now, I'm going to make sure that, because this is, again, I don't know if I can put P of X in here. I've never actually tried that. Okay, but it does work. It looks like it works. So this is saying that the function P at X, and this is without anything going on. And it looks like we have a line graph because that red line is supposed to be our function. Now, the last one that we asked was, what if X was 18? Which I just plugged in. So right here, I have a vertical line at 18, right? So 18 is the X value. And if I go down here, the Y value would be negative 23.5. And that's actually what we got. We got negative 23.5. And this will work with pretty much any of the functions that we worked on. So like, let's say number 7. So if you got your packet in front of you, let's look at number 7. I'm gonna make another line where X equals, what was the input for that one? Negative 19 over 16. And what was that? We got negative 1.85, which I think we actually should have gotten 5.4. So is there something that's not quite working out here? Oh, wait, that's 9/16, not 19 over 16. Because that didn't match what we were doing earlier. So now it gives us the decimal of negative 9/16, which 9/16 is a little bit more than half, right? If this was 8/16, it would be exactly half. And we know that like 0.5 is half, so this extra little bit of number comes from this being slightly larger than half. But we still get an output of 1.25. So if I put in negative 9/16, I will get 1.25. And I can also, again, do this with any number. So if I use my slider, I can pretty much get any number. Like looking at here, like what if it was negative 2? Well, if it was negative 2, that's the number I would get out. If it was positive 2, this is the number I would get. So that's what the function is. It's like, where are these two parts on the line? right? So if I wanted to know 6, I could just go to the line and click on it and it would say, so if my input was 6, I would get out negative 7.5. And that's a useful tool. Now we still have to learn how to evaluate these things. So don't just be using the function, the graphing calculator for everything, because even though it probably will work, you're not really learning much from it. Okay, so the purpose of this is to learn how to evaluate a function, which is why I don't like certain other types of tools that will help, you know, give you the answer, because it's just, you'll get the answer, but you know, the whole point of this math course, anything really in school, is to learn how to do it on your own. Whether or not you'll actually go, you know, after high school, you're actually going to go and use them. It's really more about exercising your mind and learning how to do new things that you wouldn't otherwise know how to do. All right, so with these ones here, it's kind of similar to the other ones we did, like what number was that? So like in this one, number 5 right here. So you have some things going on. So in this case, it looks like we're still going to use our same function, so Q. And I just didn't have enough room to write this on my last slide, so I'm going to go ahead and look at my packet. So Q is negative, not negative, it's the absolute value of 3x. So in this case, I get 4.5 minus x to the third, so 4.5 cubed, and absolute value bar ends. So now I'm going to have to use my calculator. 3 times 4.5, and that would be 13.5 minus, and then I have 4.5 times 4.5 times 4.5, because my calculator does not do that. It will not it will not show me what I need. I'm not able to get the cube, so I have to punch it in 3 times over. So anyway, in this case, it looks like we get 91.125, which is about 91 1/8. It's a good thing we're not using fractions for this one, because this one would be a lot tougher to use as fractions. Now, if a problem gives you a decimal, then it's okay to give the answer back as a decimal. But for this one here, I would say that we should do decimal. But if you're not sure, try to do it in fraction. If you can't do it in fraction, then you try in decimal, okay? And then let's go ahead and I'm going to multiply this out. So I get 77.625 if I subtract this from that. And it's going to be negative. And I forgot to put the little absolute value things on there. I kind of knew they were, I kind of knew it wasn't really going to make a difference, but anyway, so I know that this is going to be negative 77, all this stuff here. But once I take the absolute value, it'll be positive 77 and 0.625. Now I have to take this 7, because we didn't do anything with it, and 7 minus that number. All right, and from here we should be able to get, well, I don't need to write it, because in this case, the function notation, if there's anything else on the outside, then you don't really need to put all the steps in there. So let me get my calculator back out. All right, so in this case, what we get is negative 70.625. Okay, well, that would have been a lot easier, because all I had to do was minus 7 from this part here. Now again, well, actually, I was kind of thinking about using the graph on this one, because you could easily plug it in. Well, actually, you know what? Let's try that. I'm gonna try that. I'm gonna try going to the graph for this one here. So in this case, it looks like we have a p of -1. All right, now we still have to times it by 3 and add 5. But let's just see what happens if I'm able to put in -1. So the only reason I'm showing you this way is to remind you that the graph and the function and the equation are all describing the same thing. So I should be able to get an answer out here, which in this case, it would tell me to get a fraction. And this doesn't really help a whole lot. We would get 1.8333. So I guess we could do this as a, well, hold on a minute. This is actually a common fraction. So when something ends in 0.33, that usually means that it's a 6 as a bottom number. So I'm going to try this out, 11 divided by 6. And that is actually what we're looking at, 1.8333. So numbers that will repeat like this, okay, you don't really need to know this. This is a lot of information. So if it's too much, don't bother with it. But if something usually ends in 0.3333 or 0.6666, then that usually means your bottom number is 3 or 6. Anyway, so at least with this one, I know what the fraction is, okay? So that saves me a little bit of crunching this stuff here, but again, I still have to multiply it by 3 and add 5. And again, you could just plug this in to the p function, which I just didn't want to go over it because if you look at your packet, they're on opposite sides. So, and I already had the graph there, and again, the purpose of that was for me to show you that you can use a graph as well to get your answer, because again, it describes the same thing. All right, so what do I got here? 33 over 6 plus 5. And let's see. Well, let's, I'm gonna use my, where can I write this? I'm gonna go ahead and write it right up here. So 33 divided by 6, and I kind of already know what this is. So 6 goes into 33 5 times. Get a remainder of 3 6 left over. So that's 5 and 3/6, which is 5.5. Oops, not 5. This becomes 5.5 plus 5. Now this is a pretty easy one because if you were to convert this to a decimal, it would be 5.5 plus 5, which is actually pretty easy. In this case, this would all come out to 10.5. Okay, and that's it for those ones. Now these ones are a little bit different. Think back to that example that I was talking about just a minute ago. Okay, so I'm gonna ask you a question. So it goes back to the Pringles because it's just what I have. You know, I don't know. Well, it's just because the store around the side of the building nearby sells these, and I don't know. I just like, I don't know. I guess I'm just in a phase where I just like Pringles. Anyway, so I'm gonna ask you a question. If I said that I have $8.45 worth of Pringles, and remember, they're $1.69 each. So if I have $8.45 worth of Pringles, how many cans is that? So you're probably thinking, wait a minute, I can work backwards because I know, like for instance, 3 times $1.69 was $5.07. So it's probably a little higher than 3, which in this case you might try another number like 4 or 5. But anyway, the purpose of that question was, can we work backwards? If you know the price of something and you know the total of how many different of those things were bought, could you tell how many of those items were bought? Yeah, that's right. You just kind of work backwards. So in this case, that's kind of what's happening with this question here. So they want us to use this 3x plus 19 for our f of x. So what we have to do, and this one's kind of a confusing one. I kind of agree. It will be a little confusing at first. So 3x plus 19. Now here it says the output. The f of x comes out to 34. So normally we would do something like this, but in this case, replace the f of x with 34. Now again, this one's a little bit different because we're not solving it. And we're kind of not, or actually, hold on, let me back up a bit. We're not evaluating it, we are solving it, because we want to know what this x has to be in order for us to get 34 from this equation. And then from here, it's not so bad. We're going to go ahead and minus 19 from both sides. And I'm going to solve this just using use our basic algebra. So start with our addition and subtraction, and then move on to any multiplication or division. So in this case, I'm going to divide everything by 3. And I'm also going to flip the sides so that I get x here. So obviously 15 divided by 3 is 5. So now I know that 5, I'd have to, whatever this is, I'd have to plug in 5 in order to get 34. So again, we know the total and we know how much each one costs, but we're trying to find out how many of whatever was bought. So with this one here, I got 62. So I'm going to go ahead and just write this one the whole way. So negative 62. So we know that this is the outcome. This is the output. What we don't know is what the x has to be. And in this case here, it looks like we would have, we'd have to minus 19 from both sides. So they're both negative. So negative 62 and 19 together would be negative 81 equals 3x. And I'm going to go ahead and divide both sides by 3 again. And 81 divided by 3, I think it's like 27 or something like that. 81 divided by 3, and that would be 27, so x equals. Oh, and don't forget the negative also, because this negative right here is still there. And I'm going to flip the sides too, so just flip them so that x is on this side now, so divide that, and this side has negative 27 on it. So I just flip the sides. So now x is the one that goes first. Okay, and it looks like we got 2 more slides to go, and I think these are some of the rougher ones to go over. So next one here is word problems, and I kind of wish there were more word problems sometimes. I think a lot of students really don't like word problems, but it's one of those things you just got to learn how to do, because math isn't very useful if you don't know how to use it. Anyway. So Owen paid a landscaping company $108 for initial lawn treatment, then $74 per month thereafter. So it looks like we already have a function, P of t equals 108 plus 74t represents the total amount of money he will have paid after t number of months. So t is time in this case, time in months. So find P of 24. So P of 24. So now it looks like here we're plugging this in. So P of 24. So we want to use the function that they gave us, 108 plus 74t, which in this case is 24. Well, remember what it means. T is time in months. So if T has been replaced by 24, that means that this has been 24 months, or maybe a year. Okay, so this has been a year. So in this case here, I have 108 plus 1,776. And add those together, you get 1,884. Now remember, this is, well, it says what does it represent? So what does something like this represent? So again, we're talking about 24 months. So in 24 months, our guy Owen, well, let's capitalize his name, will have paid, let's type that amount, $1,884 in lawn care. Okay, we probably didn't have to put that last part there, but I like to be a little bit descriptive. So this tells us that Well, normally, well, this is kind of the normal way we would do it. We'd put an input in, right? So maybe Owen wants to know how much he paid in 2 years worth of lawn care. So that's like almost $2,000. Some people really like their lawn, I guess. I wouldn't pay that much for a lawn. Well, I do get tired of all the sand, actually. Anyway, so this one's a different question. It's the same question. Well, actually, same problem, different question. So how long has Owen been receiving lawn service if he has paid a total of $2,994 to date? So this means we don't know. We don't know the time. So paid, we don't know the time because it's asking us right there, how long has he been receiving lawn service? So that's a clue that we don't know the time. But we do know that the total is 2,994. So what this means is that we're gonna have to plug this in to our formula, 108 plus 74t. So this means that we don't know what the t is. So I'm gonna take this 2,994 number and plug it in as the output. So we know this is the outcome. This was in the total, and that's what you pay. So it's kind of like, again, the Pringles cans where, you know, if you buy $8 and whatever, I think it was $8.45 or so. If you paid $8.45 in Pringles, that's about 5 cans. So we're working backwards now. So with this one here, looks like we're gonna have to minus 108 from both sides. So minus 108. And that should give us the next step. So this would be 2,994 minus 108. And that would be 2,886 equals 74t. And then from here, I would have to divide both sides by 74. Divide both sides by 74. And this comes out to, and I think we're ready to get our answer because once I divide this, should be able to get what we're looking for. So t equals 39. So now we know that the time is 39. So we knew the output, but we needed to know what input we will use to get that particular output. So in this case here, we now know if he had paid $2,994, he would have been paying for this lawn care for 39 months, which, let's see, 36 months would be a year. So this is about a year and 3 months. So a little over a year. I'm sorry, a little over 3 years. And again, that's quite a lot of money. I don't know if I'd spend that much money on a lawn. But I don't know, maybe he got a big house or something. All right, now it looks like we're on our last set of questions here. And it just goes to this last page, and that's going to be it for today. All right, so use f of x and use negative 4x plus 9, and g of x is going to be x squared minus 5. Okay, so let's go ahead and now these ones here, we're not just plugging in one number, which so far that's what we've been doing. We just plug in one number. With these ones, it looks like we're gonna have to plug in multiple things. So let's go ahead and use our f of x. So we know that that's gonna be negative 4x plus 9. But in this case here, x is actually gonna be 2 things, and that's gonna be c and 2, or c plus 2. I'm gonna use distributive property. So I get negative 4c, so distributive, and then minus 8. And since I used the distributive property, the parentheses will be gone. So I'm going to go ahead and put the plus 9 there and combine my like terms. So negative 8 and 9 are both like terms, which actually they do not combine with c. So 9 minus 8 would be 1. So that's it, I guess. That's as far as we can go. I don't think we can do much else. We could probably write it in function notation. So f of c plus 2 is equal to negative 4c plus 1. And box this up. Yeah, use a green box. Green's just sort of the natural color things are. That's a really bad box. Oh well, we'll come back to it later. Let's go ahead and keep moving. So in this case here, I have same thing, f of, so let's go ahead and plug in negative 4x plus 9. But again, instead of plugging in one thing, I'm going to be plugging in multiple things. So in this case, I get 7w minus 5. And same thing, I'm going to have to distribute the 4 to both sides. So that's going to be negative 4 times 7. So that would be negative 28w minus, and then, oh, actually, that'd be plus, because don't forget, anytime you have a negative on your outside number that's supposed to be distributed, that's actually going to cause this one also to be multiplied by a negative. So negative times negative would be positive 20. And then again, we used up the distributive, so that way there shouldn't be any of this left over. And I think we're ready to write the answer. So f of 7w minus 5 is equal to negative 28w. And then 20 plus 9 would be plus 29. And again, it looks pretty tough, but it's actually not that bad. You just sort of do what you can. Some problems, if they you can get it all down to one number, like all the other ones we've worked with. But sometimes you might have several different parts of your answers. Like in this case, we have a negative 28w and a 29. So that's as simple as we can get it. So if you can't, simplify it all the way, sometimes you just gotta go as far as you can. Okay, so for g, we're gonna need this one here. So x squared minus 5, x squared minus 5. And now I need to put in negative 4y to the third. Oh dear me. Okay, so we're gonna have to square this. This one's a little bit different. I don't think we've seen anything like this yet. But if you have a parenthesis with a power, you have to square everything in the parentheses. So it's kind of like distributive property. So negative 4 times negative 4 would be 16. And the y, they multiply together. So it's like I have y to the 3. So if I imagine like y to the 3 is 3y's, another 3y's, and another 3y's, then I would have, wait, hold on. No, I'd only have two groups. So 3y, a second 3y. That would mean that there'd be y to the 6. Whew. Okay, yeah, that one, oops, undo. There you go. And then the negative 5 is there. So I cannot combine these two things. So I think we're done with this. So if I plug in this for g, I should get 16y to the 6 minus 5. And again, I'm not really sure how everybody feels about that. But again, you just square everything in there. And when you square a power, you multiply the powers together. And there are actually some other rules like raising a power to a power, which is what this is. Or you would also be adding powers. So they're a little bit different. Multiplying powers, yeah, they all have a little bit of a different thing going on. Anyway, let's go ahead and do the same thing with this one here. So wish there was a way I could just cut and paste this. So x squared minus 5, oops. There we go. And again, I have to put in a minus 3. And This is a pretty tough one. In fact, if you miss something like this on the homework, I'm not going to hold it too much against you, because this is one of these other things that we kind of, I think we'll cover later on in the course in more depth. But basically, when you see a power on a parenthesis, and there's two elements or more in that parenthesis, that means you have two groups. So here I have a group of a minus 3, but it's telling me it's squared, so that means I have one group and two groups. So that means I have two groups of a minus 3. Now from here, you're going to have to use something that we call FOIL. And that stands for first, outside, inside, last. All right, it's probably better if I just type it out. I did it a lot faster and a lot nicer. And it fits in there too. So what I got to do is multiply the first two numbers in each group. So a times a is a square. Now for the outside number, so the two farthest away, now for the 5, the negative 5, we're just going to ignore that entirely. Just forget it's even there. And that would be negative 3 times a. So negative 3a. And then the inside numbers. So the two numbers in each group that are kind of closest to each other, which in this case is also negative 3 times a. And the last number, so the last number in this group and the last number in that group. So that'd be negative 3 times negative 3, which would be positive 9. Now again, I can't completely ignore that 5, so equals, let's go and put these together. So a squared, negative 6a, because I put the two negative 3a's together, and now 9 minus 5. So 9 minus 5 will be 4. And there you go. So I have an a square here and another a here, but they're not exactly the same, even though they're both a. So I know I've said in the past that it's a like term if they have the same letter, which in this case they are both a, but there's also a second part of that rule. I think I mentioned it, but I was kind of light on it. And that is, they also have to have the same power as well. So one is a 2 power a, the other is a 1 power a, which this one doesn't have a visible power, so it's 1 power. So they're not exactly the same thing, so I can't put them together. And that's our final answer for that one. All right, let's go ahead and do this one. So I have 2 of them, and this is going to be very similar to that other problem we worked on, number 5. I think this is the second time we're going back to that. So anyway, let's go ahead and put g here. So g is our second function. 2m plus 1 squared. Now normally I write the whole thing in first. Let's see, g is minus 5. I said minus 5. Pushed the wrong button. Arg. Okay, there we go. And double check that, make sure it's gonna work out. So again, I took this and I plugged it in, and which normally I write the whole thing in first and then I fill it in, which again, that might be a little confusing. So now I have 2 groups of 2m minus 5, or plus 1, I'm sorry. Getting a little ahead of myself. 2m plus 1. So I expanded that out, and I still have this minus 5, because that one comes from the equation up here. And I'm going to have to multiply this out. So I get 2m times 2m, my first 2 numbers. So that's 4m squared plus 2m plus 2m. So my outside numbers, the 2 farthest away, 2 times 1 is 2, and then m. And then my inside numbers, 1 times 2m is also 2m. And I still have, I still have the last step, and that's the last two numbers, and that is 1 times 1, which in this case 1 times 1 is 1. And I still have a minus 5 on the outside. That minus 5 is completely just sort of thrown in there. So 4m squared plus, and I'm just combining all my like terms. Everything that's a like term, I'm putting them together. So 2m and 2m is 4m, and then 1 minus 5 is negative 4. Whew, okay. Now I got to remember that there's a minus here, so I'm going to put this one in purple. Okay, that's purple. You can barely tell because I have to minus this from this second part here. So this second part is our f function, so we need this one up here. And that's going to be, and I'm going to go ahead and do the same thing. I'm going to put negative 4x, which in this case, our x value is going to be 3m minus 7. And then use our distributive properties, so negative 12m. And then negative 4 times negative 7, so that would be plus 28 plus 9. Okay, and then combine our like terms. So in this case, it would be 12m plus 9 and 28, so that'd be 37. And I think that's pretty much it for this one here. I'm going to move it down a little bit so that way I can see here that I'm going to be subtracting this from that. And I'm going to start with my highest power, which it would be much easier to stack these numbers, but I'd have to do a whole lot of rewriting. So take our highest number, highest powered number. So in this case, it'd be 4m squared. And then I have 4m minus 12m. 4m minus 12m. You know what? On second thought, I'm not gonna skip any steps. I think. So I'm gonna rewrite the whole thing from here. So 4m squared plus 4m minus 4 minus the whole group of 12m plus 37. So remember, we're minusing this whole group. So it's not just one thing we're minusing, not like question number 5 where we only had to minus something like 6 or something like that. In this case here, we would actually have to kind of redo a lot of this here. And like I said, I was kind of hoping to avoid all the extra writing, but it looks like we're gonna have to, it's gonna have to be done that way anyway. Now, this is one of those things that I said early on was going to be super important, and that is whenever you have a minus in front of a group, that's usually a sign that means that you are going to be subtracting everything in that group or make everything minus, change the sign on everything. Now this is going to be this is going to make it a little bit easier to put our numbers in, because looking at it from here, I can see that I have 4m minus 12m, which would be 8m. So minus 8m. And then my regular numbers, I have negative 4 and negative 37, which would be negative 41. And this is a lot to write. And actually, in some of these, you probably didn't really have to write all of it. So like if you this is the main important thing I'm looking for right here. So if you just wrote that part, I'd probably accept it. Even though I know I was saying that it is one of the objectives that we write this stuff in function notation, which I would prefer you do, but so in some cases you just can't, well, it's just a lot of work to rewrite the entire thing. So in that case, I'm going to go ahead and not rewrite all this stuff here. So we just have so much stuff going around. Or if there's anything going on, like if we're adding two functions, or if we're doubling a function, or adding something or subtracting something from a function, don't worry about it. But like I said, even if you put it like this, I think I'm still going to accept it if you just put negative 4c plus 1. So this is also acceptable, just something like that. Whew. Okay, so that pretty much came out to be an entirely full-length video, but that's okay. We didn't miss anything. We didn't skip anything. We covered everything in far greater detail than if I had tried to cram this into yesterday's lesson. So it all worked out. So that's it for this lesson. If you have anything else, I'll be around for a bit. But otherwise, we are done with this lesson. So I will see you